And welcome back for a tutorial on how to use the Whales user interface for an unconfined case. So first, let me start with a brand new problem like I introduced in the lecture. This is data for an unconfined aquifer. We are given the discharge, 2,500 cubic meters per day. The observation well is 45 meters from the pumping well, and this is the data. So first thing first, let's grab the data, copy it, and remember that you have to put this in your okay, so now we pasted the data. This we don't need. Let's just do no fill. Okay, so this is the data for the problem statement. We said Q was 2,500 cubic meters per day. Let's check this data. 2,500 cubic meters per day, and now we have R is 45 meters. Okay, so these are where we start. Again, this data now is on the right hand side here. We want to fit it first to the type A curve, so on the left hand side of the graph. So if I go to here, let's say 1, that's still too much, do 0.5, that seems about right, and now we probably want to shift it up and down a little. So let me, what do we have, 0.04, 0.02, we want to shift it down, it seems like. Yeah, that's actually pretty good. Yeah, I'm not sure, maybe I can, this seems to fit all right, but on the left hand side here, this is pretty perfect fit. I'm sure you could fit it also to 0.025, let's say. Yeah, even like 0.028 maybe. Yeah, to get to that orange curve. So it's really one of those curves. You could pick that blue curve or that orange curve. They both fit pretty well. So let's leave it here for now. This orange curve is gamma equals 1.5. Again, you look at this color here, is the same as this one. So 1.5. So we want to come here and put 1.5 in our gamma. Now at this point, this calculates transmissivity and storativity automatically. And of course, we already know this because these are the results we saw in the example in the lecture, okay? So 140 square meters per day, and then the storativity for this aquifer, 1.9 E minus 4. Now, notice that this is not a real number, the specific yield, right? Because now that's why we need to use the B-type curve so we can calculate the specific yield for this aquifer. So in order to do this, we need to shift the data to the B-type curve, so to the right. So again, we don't touch W, we don't touch the y-axis, we only touch the x-axis, and we had that before. I don't remember what number I used for this, but let me try, what, 5 maybe? Yeah, 5 is pretty good, even 6 maybe, just switch it a little tiny bit more. Yeah, there you go. And you can see that on the B-type curve here, we have almost a perfect fit of the data with that orange line. So of course, gamma didn't change. Again, when you fit that B-type curve, do not change the y-axis, only change left and right. Just go fit that B-type on that same gamma curve, on that same 1.5. So now that we're here, you can see that automatically our specific yield, changed to about 16%, which again is, a normal number, if you will. That's a number that we can believe, right? Again, specific yield cannot be more than 1, of course, right? That would be 100% of the water draining. So 15%, 16% specific yield is normal. And again, this is specified here for A-type only, for B-type only. So you read storativity on the A-type curve, and you read specific yield on the B-type curve. Again, remember that 1 over UB is 10,000 times or 10,000 times less than 1 over UA. So this is all accounted for in this formula here. This is done automatically for you, so you don't have to worry about it. So again, only change those red lines, you know, the data, what's provided, and then fit the data with those shifting left and right and shifting up and down, and then finally shift the B-type curve by just increasing 1 over UA, you know, a ton, so that you get a good fit, and then everything you can read. Of course, if you know the thickness of the aquifer, then you can actually also calculate the horizontal hydraulic conductivity, like explained during the course. And here are all the equations that were introduced in the lecture video that we are using here. So yeah, that's how you use that little Excel interface. And of course, the well functions are tabulated here. So this is the unconfined, and this is the one that we use for just the semi-confined or the artesian well function for the leaky confined aquifer. But this is the unconfined complete one. And this is the interface you can use. All right, thank you.